2 projects. In this video, we are going to explain about a project titled Deep Learning for Detecting the Cyberbullying across multiple social media platforms. Cyberbullying is on social media causing a range of harmful consequences from short-term anxiety to tragic suicides. The complexity of identifying such bullying is underscored by the subjective nature of its definition, the platform-specific semantic nuances of language, and the diverse communication style across the social platforms. Existing cyberbullying detection methods are hindered by the focus on single platform, limited semantic scope, and dependence on handcrafted features. To address these limitations, we propose the leveraging deep learning model that can transcend these barriers and apply the insights gained from one dataset to other. By enhancing the cyberbullying detection, the aim is to facilitate the prompt intervention and appropriate measures based on the perceived severity of online posts. The objective of the cyberbullying detection method is the obstacle like concentrating solely on the specific social media platform, tackling on particular cyberbullying theme, and depending on the particularly crafted data feature. To surmount this challenge, our approach introduces the deep learning basic model that transcends these limitations and facilitates the knowledge transfer between the dataset. Additionally, our research offers the valuable perspective on cyberbullying detection, demonstrating the superiority of these models over the state-of-art techniques across the diverse topics on the different social media platforms. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 on Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. We need to import the necessary libraries and modules such as TensorFlow, sklearn, Matplotlib, Cburn, and to facilitate the data manipulation, visualization, and the model creation. And the next one is exploring the dataset. Through examine the dataset containing of social media posts or message that can use to try and test your model, understand its structure, feature, and the distribution of data. And the next one is visualization using Cburn and Matplotlib. Utilize the libraries like Cburn and Matplotlib to visualize the data pattern, trend, and the relationship among the variables. This step aids in understanding the distribution of classes, potential correlations, and any data processing needs. And the next one is data processing. Prepare the dataset for the model training by addressing the missing value outliers and other anomalies, cleaning the data, ensure the better model performance. And the next step is tokenization. Transform the test data into the numerical format. Tokenization break down the test into individual words or subwords, creating a format suitable for the machine learning algorithm. And the next step is feature selection. Choose the relevant features or attributes that will contribute to cyberbullying detection. These include the test content, user metadata, timestamp, etc. And the next step is data splitting to the train and the test. Split the dataset into training and the testing set. The training set is used to teach the model while the testing set assesses its performance on the unseen data. And the next step is building the model. Create the various machine learning and the deep learning model to detect the cyberbullying. Some of the model are of the first one is name-based. It is a probabilistic classification algorithm that effective for the test-based tasks like cyberbullying detection. They assume the independence between the features words that calculate the probability of the message belonging to the specific class as cyberbullying or not. And it uses the need to process the test data, convert it to suitable numerical representation, and then train the model on the label data set. And the next one is random forest. It is an ensemble learning method that combines the multiple decision trees to make the prediction. It's robust and less prone to overfitting. In this contest, we will train a random forest classifier using the features extracted from the test data. Each decision tree in the forest is trained on the random subset of the data, and the final prediction is based on the majority vote from all the trees. And the next one is SVC, Support Vector Classifier. is a powerful algorithm for both the linear and the non-linear classification task. It works by finding the hyperplane that best separates the different classes. For the test data, we will need to represent the test in the numerical format using the TF-IDF, and SPC will find the optimal decision boundary to classify the message as cyberbullying or not. And the next one is logistic regression. Logistic regression is widely used linear classification algorithm. It's simple, interpretable, and serves as a baseline for our project. It detects and transforms the test data into numerical feature and then train a logistic regression model. The model learns the relationship between these features and the likelihood of the message being related to the cyberbullying or not. And the next one is voting classifier. It combines the prediction of multiple individual models to produce a final prediction. It be composed of the combination of the models like of Bayes, random forest, SPC, logistic regression. The prediction of each model are voted upon and the class with the most vote becomes the final prediction. And the next one is LSTM. LSTM stands for Long Short-Term Memory. Is a type of recurrent neural network designed to handle the sequence data like test. It's well suited for capturing the dependency and the pattern in sequential data. In this project, it is used to model the sequential nature of the social media message by training an LSTM model on the label data. It learned to recognize the complex cyberbullying pattern that span the multiple words or the sentences. And the next one is GRU, Gated Recurrent Neural Network. It is a type of recurrent neural network similar to the LSTM but with a simplified architecture. It's effective for capturing the shorter term dependency in the sequential data too. And the last one is LSTM plus GRU. It combines the combination of LSTM and the GRU layers. And the neural network architecture allows you to harness the strength of both the models. For instance, if we use the LSTM to capture the longer term dependency and the GRU focus on the shorter term dependency, this hybrid architecture can potentially improve the model's ability to detect the cyberbullying across the various lengths of the test. And the next one is user gives the input. Here we are allowing to give the input by the user with the help of the Flask as a web interface. And the next one is the given input is translated and pre-processed. Pre-process the user input in a manner consistent with the training data. This includes tokenization, test cleaning too. And the next step is trained model is used for the prediction. Utilize the trained model to predict whether the input contains the indication of cyberbullying. Each model prediction be based on different mechanisms. And the last one is final outcome is displayed. Present the user with the model prediction regarding the presence of cyberbullying and the input content with the help of the Flask as a web interface. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing the various files within it, and the static folder containing of the CSS, JavaScript, images, and folders within it, and the template folder containing of typical HTML documents. It include of home, index, result, sign-in, and sign-up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on enter button. We need to write a command that is python space app.py. By using this command, it will execute the Python script to perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address. Like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we need to get an page with the title of the project and some information about it. and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password that are need to be filled, and then click on the register button. It will redirect it to this page containing of the dialog box where we can enter the message here. By this message it will predict it. And I'm entering the message. He burned in August. Auckland, New Zealand. And then click on the predict button. Here it predicted the tweet is not racist and sexism. And by clicking on the prediction button, clicking on back button and the refresh button, here we can re-enter the other message too. And this user as such worthless boredom fag out, and then click on the predict button. Here this tweet is not racist and sexism. And by clicking on the prediction button, here we can see the 3-1, and by clicking on the tweet button, here we get this is screen, and form string button. Here we can enter the other message by using the form string messages, and then by clicking on the wiki button, here it redirected to this input file where we can enter the other messages here. And I'm entering the message that as of like this, and then click on the predict button, and here it predicted as the input attack is based content. And then click on the form string button, and here we can re-enter the other message too. And enter the other message where as well as have been on here for a few months. If you are referring to on a place page, then that was just a mistake, sorry. And then click on the predict button. Here it predicted the input is non-bullying content. In this way, we can predict whether the message is bullying or not bullying by using 3 various data sets of tweet, form string and wiki. In this way, we can detect the bullying of using the various multiple social media platforms. And in conclusion, the deep neural network models can be used for cyberbullying detection across the multiple social media platforms and the various topics. The model coupled with the transform learning were beat of state-of-art results of all the 3 data sets used in this experiment. We suggest that these models can be further improved with extra data such as information about the profile and the social graph of the users. We also note that the most of the current dataset do not provide any information about the severity of bullying, and if such fine-grained information is made available, then the cyberbullying detection model can be further improved to take the variety of actions depending on the perceived seriousness of the post.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.